Okay, I'm here today with Devishri Nayak from the University of Washington Tacoma campus and Jessica Grisholm from Valencia College in Orlando, Florida. They were two of our incubator participants that actually had some time to work on a new tool that will help the students and the community to learn a little bit about the encryption. So without further ado, I would like to ask the participant, what was their project?
So hello everyone, Devishri Nayak, working as assistant teaching professor, and the project was we actually got to work with different components of cryptography, and we developed a scenario from the scratch, which was based on water treatment facility, and we used crypto tools to introduce different components of classical cryptography, modern cryptography, different algorithm, and kind of created assignments based on the particular scenario for students, K-12 students, who can have a wonderful experience sharing their knowledge and also getting to know the tools. And Jessica and I work together in the same group, and we kind of developed it from the scratch. And Jessica, would you like to add something to that as well?
Yeah, it was we were able to go ahead and, using the same scenario throughout the entire incubator, be able to create some summative assessments based on labs that were already produced. And the goal was to be able to, once a student learned something about classic encryption or cryptography, they were able to go ahead and do an assignment that kind of challenged them a little bit to see if they actually have the knowledge in order to be able to understand classic cryptography. And so there was 5 categories that we worked on. And so our goal was to go ahead and try to create those more of the challenge labs to allow the students to see if they've really gained knowledge from using the crypto tool. So that was our purpose. And so, yes, we did go ahead and work collectively together in a group throughout the entire process.
Fantastic.
To add to that as well, I would also like to mention that this particular project not only gives students an experience learning about the tool, but also introducing them what can be the real life scenario, which in a day-to-day activities like already happened. If we talk about like Florida water treatment facilities was impacted and kind of adversaries was targeting. So that's kind of like giving them that experience that real life scenarios can happen that way, which will help them for their future as well, apart from the going through the assessment and learning about tools and cryptography, different components.
Fantastic. So, Jessica, can you tell me, what do you think that the value of the deliverable will be?
You know what? I think that it was overall one of the best things I've ever worked with, as far as working together in this environment in an incubator and being face to face. The value of this tool is phenomenal. I think it's a great way to be able to showcase and show students. The labs are designed in a way that they actually can physically see. Cryptography is a very it's not one of these ones that you can really show students. So it's very difficult to really be able to piece point A and point B. The tool allows us to kind of do a visual representation of it that gives the students a better idea of how cryptography works. So the labs are laid out great. And then being able to use it, see the labs and how they were designed, actually allowed us to create labs that were able to challenge them and say, okay, you got to see it, you got to watch it. Now, do you really understand it? So it's a wonderful tool. I'll tell you that right now. I think that through K through 12, it's a great way to introduce cryptography. I think a lot of times people don't really quite understand what happens in the background when we use these tools. And so the value to this is, I think there's a tremendous amount of value, not only just creating them ourselves, because I think the tool was kind of interesting to use myself, but just to see what this is going to allow our students to be able to do.
Perfect. Go ahead.
Nope, I don't have anything else. That's it.
Sorry. Anything you have to add, Devishri?
So the value, what I find in the project incubation, particularly 2 to 3 days and kind of follow up in this particular workshop, coming all faculties from all around the United States and coming together, working on a team, having brainstorming ideas of like, because cybersecurity in an environment where it's continuously changing. And when we talk about cryptography, when we see different algorithm, it is important we should introduce students as early as possible, which is K-12 in this particular environment, and community college, which generally in a traditional studies environment, we introduce maybe later in college. So having this experience and going through brainstorming with our faculty colleagues who actually teach across the United States, like I teach at the University of Washington, Tacoma campus. So my student population is very different from Jessica's student population because she teaches in Florida, same as it is students who are in Illinois environment and Chicago environment. So coming together, having this brainstorm and understanding student population, their strength and weakness, and develop a particular assignments and assessment from the scratch, which will actually serve to the larger audience, is impeccable. So this kind of project incubation, I wish happens many times in the year, so that we all can come together and have this assessment and make it available for other teachers to teach and students to participate. Can be a great opportunity for not only faculties, but for other educators and our students as well, to kind of fill this gap cybersecurity which United States currently facing.
I agree 100% with you. I think that it was a great opportunity to be able to meet colleagues around the country, and I'll put it on film, is to say that it was one of the best workshops I've been to in a long time, and I think that they really should consider more opportunities like this to allow us to get together. I think that if they've got such a national issue with it, then the best way to approach it is to have more workshops and brainstorm exercises like this to allow a greater audience to be able to participate.
Exactly.
Perfect. Thank you. So would you say that because you participated and you actually developed the labs, you are now more likely to use the materials?
I would say yes. I think that once I saw what the visual tool, the crypto tool could do, I think I could probably say that even in an introductory level, even in an associate's program, that it's actually a good tool to it's not just K through 12. I think a lot of older students don't have that same visual representation. So I think in that way, yes, I know in a collegiate academic environment, I'm more prone to give more challenges and maybe give less information. But I think to start with, I think this is a great way to start. It's a great way to say, hey, let's take a look at this. However, later on, you're going to get bigger challenges because of the fact of where they are academically.
Perfect. Thank you both.
Thank you. To add to that, I teach both undergraduate and graduate students who are transfer community college students. Many times, not only real life application, but also in an IT perspective, right? Whenever we are saying like we are teaching a networking class or network security class, we introduce cryptography as one module. So when we are talking about RSA, they may not be using directly, because if they are not going to be cryptographer, they may not be using RSA forever. But this type of algorithm, or we talk about MDS5, like other algorithms, we can actually show them, pull the templates using crypto tools and see. So this is how you are actually inputting the data. This is how output, and this is how this algorithm works. So whenever you are applying some kind of algorithm as a part of encryption, when we talk about data encryption, which is very, very important component, whether it's a network security, whether it's other form of security, different protocols, they are able to visualize that what is happening within the network. And many times we may not have enough tools to represent how the environment and encryption happens unless they are getting a job or internship. But with this tool, we can have a step-by-step visualization process, which is very, very important for students, undergraduate, and if I say like a graduate students as well.
Fantastic. Okay, would you like to demonstrate some of the labs that you actually developed for us?
Yes, so we both actually will be participating in this particular demonstration, and this is because this is a real life scenario we developed from the scratch. So we will start with classic cryptography, and that's the first lab we will be pulling up. So this incubation, we kind of shared a canvas, and this kind of particular canvas we kind of created of our lab, and this is the scenario based on water treatment facility. So so this is the first lab where competence we started, which you can see the Green River water treatment facility, which is a very hypothetical scenario. And especially each lab has introduction, objective, kind of topology, how the cyber attack happens. So in this particular one, particularly like the scenario was, well, students or particularly like participants who got the scenario where they've been hired with the cybersecurity intern as a Green River, Puget Sound, Washington, because of like we kind of trying to merge together of our diversity, both Jessica's and I, which is from Florida to Puget Sound, Washington, particularly like this critical infrastructure facility that supplies clean and safe water for a large metropolitan area. And the adversaries are trying to like particularly have the using like environment, which is a remote environment, and trying to steal sensitive data with the control system using their skill set with unauthorized access. So the objective is making sure that we validate the classical cryptography knowledge. So the students and K-12 students who are participating in this and kind of pertain the classical cryptography real world environment. So, so Jessica, would you like to explain what is happening in this particular attack scenario?
Yeah, I mean, the one thing I do want to preface is this is collectively built off of an actual event that actually occurred, which is really important. As an entire group, all the other sections that we're working on different areas, we all came up with one attack scenario, and this is something that actually happened. So it's adding that real world element to it, and so we learned a little bit about water treatment plants as well before we started making these scenarios. So the scenario is based on something that did occur, not necessarily the names have been changed to protect the innocent. But in this case, the classic cryptography, we started off just with the attack that happened. And so they actually receive a message on a terminal window that says something that they obviously can't understand because it's been encrypted, or it's been encoded. So in this one, they're trying to investigate. So throughout all the process, we created it where they have to kind of read a little bit of a narrative. That narrative is explained something that's occurred. And then from that, we went ahead and implemented either classic, modern, or whatever type. This one happens to be classic. So we just start off with a simple Caesar cipher. And so the goal is to be able to decipher the message first, which is starts with the bold EBQ. And so they have to take that message and they can use CryptoTool and they can actually decipher that message and answer the questions that go along with it. So throughout this, there are 10 questions for classic cryptography. Scroll up a little bit. Yeah, so, thanks.
So these are the questions, and the answers we have added for the teachers' purposes and for the reference purposes, but students will not be able to like see all those are the keys which are not included. So I would like to pull up the classic cryptography examples we did so that you'll be able to see the tools. So this is particularly a tool where they go to CrypTool if they will go to Google, and this is only can be downloadable in the Windows system for the better navigation, and they go to download and they need to download it. So for our classic Caesar cipher, this is the particular tool. We kind of like, added the information so students will be able to enter the information. And if we say play, you can see the output in this particular environment. It's saying urgent $1 million Bitcoin environment, which they will be able to kind of get from this particular information. And based on this text input, so this is the Caesar cyber experience where students are able to see that like how particularly in the Caesar cipher, things shifts, and it's one of the most simple and very widely known encryption techniques in the world. So students will able to have kind of hands-on experience while working with the real life scenario, which is built on top of the scenario happened.
And if they had successfully gone through the 2 labs, there's not going to be any question on how to use the tool. So the goal is they complete 2 labs that are part of the classic encryptions, and then they go ahead and they will do this lab, which gives them a lot less information. It's not going to give them step by step. It's going to give them a scenario and say, hey, look, you found this missive. Can you solve what it says? And then this tool is going to be able to say, hey, you got to give us 1 million Bitcoins. And then they're going to finish the 10 questions that they have. After they get this first question, it's going to lead them on to a second question. And a third question is going to ask them more questions about what this is, just to test their knowledge. And so they get to do some frequency testing on it. You know, what was the shift, which is important for a seizure. And then they're going to go to their next place. So we're going to point them to a new one, which is going to say they found 2 text files. They got a secret text and a message text. It's in the download folders this time. So we're also trying to lead them through what an investigation would be. You might find something on your desktop. Where do I go then? Oh, we have to go to download folder. Okay, maybe it's in documents folders. Maybe it's on our desktop. So all of these lead to the same thing, giving little breadcrumbs that allows them to go ahead and get the answers that they need. And when they're fun, they've demonstrated classical cryptography.
So this is particularly like the lab one. So like this, we have different components of cryptography. So in the lab 2, if we talk about and go back, so in the lab 2, we kind of had water treatment facility. And this is a particular lab 2 starting where we have a competence of kind of continue on the top of those scenarios. And we kind of added like, how validate cryptographic system, particularly like cybersecurity, same what are the attackers are up to. And this particular components where we kind of did forensic investigation after gaining access to the network. So again, in the top of the same scenario, which has been everybody is working, how particularly especially adversary access to the network and attackers trying to exploit insufficient segmentation access control mechanism, allowing them to move the network artifacts in several systems. So in this particular environment, they have to create in particular forensic team with the 2 suspicious files, which was instruction.txt and error.txt. And the particular 10 questions, so we have like 11 questions they will be able to understand, where they will have the experience of what is DES algorithm or different kind of ECB, and how they will kind of like encrypt the files and decrypt based on these 2 particular forensic files to add on to it. So Jessica, you have something to add on to this?
Yeah, no, this one is all about modern cryptography. So again, we went through again as if the students went through the 2 modern technologies. Now we didn't we did try. In fairness, we didn't lead them through the same things they did in their exercises, because if they understand modern technology, so this one is DES and Blowfish. So it's not going to be your standard modern technologies. We were, trying to get them to think a little bit more about it, so they can, have to research a little bit more and have to think more about what it is they have to do. But again, if they've done the 2 labs, then there's, this is the next part of it. So the attack scenario continues, like she said. So they do the 2 classical, they get it, the initial attack, and then do the modern labs, then they get the next part of this attack scenario. So each of them will go ahead and go ahead and continue the storyline until we get to the end.
So now we focus on the lab 3 continuous, which is particularly if we show that particular content, which is kind of like, they kind of downloaded a file, what is like MDH, which is a hashing components of it, like where the water panel and what are the particular questions, which is like in a hashing lab. And that's kind of like needed because of like if students have hashing experience and how they will be able to like encode and decode it. And from this particular one, students actually able to find out. So it is easier to show so that like if we see like they have different components of like in this, if we type MD5 lab and students are able to see like something, if this is an example on the top of the scenario, but we are just pulling up and kind of showing you a demo so that students also will able to know that like how to use this particular tool. So if we play that, so it will give you something like this type of output. And you can add some additional, like if we talk about something which is encryption message as a part of this question and answer, they will be able to apply that in the environment as well.
This one also, I will say it's going to be a little bit tricky because this is stuff that we face a lot. You can create a file with spaces, so water space panel space codes.txt, but then you can eliminate water panel codes.txt. Looks like the same file. So a lot of it has to do also with whether or not the students are paying attention to what the files are. But this is is reminiscent of the fact that you cannot really download anything from the internet now without checking your hash values. It is kind of a lesson in like you still have to do this. So if somebody is mysteriously trying to download different files and which one's the correct one. So it's making sure that they understand the value of hashing, checking it. So if a water code panel, and then same thing with the codes inside the actual codes that they have, is just adding a space changes that hash value. So it's an important lesson to realize that one space actually can really change a value of a hash. And so they're really going to have to pay attention to this lab to see that the fact that it's designed to be a little tricky, but it's also said, hey, there's an important reason why you have to understand that an extra space will change your hash value. And we can, the bad thing with Linux and Windows, we can create a file that's almost identical, but we can eliminate spaces and, it doesn't say, hey, you already have this file. So, but again, this one is just for your hashing value. So either SHA-1s, MD5, SHA-256. And it doesn't necessarily have to be done in this environment because hashing can be part of Linux and Windows. You have the ability to do it right directly on a machine, but this tool will actually do both of them as well.
And to add to that, if we see like, water code, one of the examples input, and we'll stop and we'll play it, you'll see that this is the hash value. But if we start using kind of like space, we'll stop. And if we replay again, you can see that the hash value changes. So which is a student's very, very important factor, as Jessica said, to learn that one space can literally play a significant role when an adversary is trying to get into a particular message or get into a particular environment and trying to send a message within their compromised sources within the network. And people, they are trying to, they build relationships within a particular attack. So that's kind of like our lab 3. And again, as we go back to particular, like next is lab 4 and 5. And in this lab 4 environment, we kind of added to
steganography, I think.
Steganography, particular environment where students will be able to see a particular picture and using, and not necessarily this tool, they have to add another tool to use, like using a picture, and how a picture, what would they see is actually not the real one, and there is a message inside has been coded, and how they will apply that. It's a very, very important factor to this particular steganography. Like the purpose of whole lab is to introduce them that picture doesn't say everything what they see, what we see. So there can be a message encoded within that. So that's the purpose. And here students particularly will be experiencing with the forensic team, working with the clock, collect different kind of recent attacks, and how they being suspicious about different pictures. They may look similar to us, like, okay, simple a water treatment design, but that particular design can contain messages from adversaries. Jessica, what do you think about like the questions, the Godzilla?
Oh, Absolutely. Steganography is one of those ones that, there's a lot that can be said about it, seeing how people have used it through the decades to hide communication. But yeah, both pictures look the same, so if they download both the Godzilla, in this case Godzilla, they both look the same. They look identical, but the truth is one does have a message behind it. And so the goal is to try to, have the students take a look at that, to realize that this can be a covert way to hide messages. It's been used and still used, which is kind of sad, but it's still being used. But it's a good way to get them have an idea that we can change just values of red, blue, green, and be able to go ahead and make a difference with it. So yeah, so they're both identical pictures. The difference is one does have a message. All of our answers also still do have to do with, believe it or not, because bugs and water treatment plant. So everything does still have to do with the water treatment plant. But so we tried to tie in the steganography as closely as we could to the scenario as well. So they're either going to find them on the desktop or they'll be directed on where to find them. But the goal was still to kind of lead them in that same direction, to say, okay, here's your next task. After you finish these 2 labs, let's take a look at some images and see what you can learn about them.
So this is one lab which has been coded, and if they will apply to this particular coded lab, and this is actually, if once they download it, particularly if they will upload there is a website in the GitHub which has been used apart from this particular tool, and they will upload, they will be able to encode it. And that particular website, particularly, let's see. Are we talking about this one? This particular, this one actually.
That should be the RSA one?
Yes.
Right.
I was trying to find the lab for the encoded one.
I think it was still in the 4th, right? Yeah, that's where
there should be a link. I think it's not been added. There was
I'm sorry, that's the GitHub one. I have to took it out because they will have no access to the internet from that path. Right. So we cannot use it. We cannot let them go to the GitHub because they will have no access. So I took that question out. I'm sorry. So there's just 9 instead of 10. Yeah.
So even if like this SHA, so this is the code, they can use it for decode it for this particular steganography picture.
Well, the Godzilla ones, I gave them the 2 images, so they're going to upload those into the NDG site.
Mm-hmm. Yeah. You'll be able to do that, yes.
Yeah.
So that particular site.
Just the GitHub, the GitHub, they will have no access to GitHub, so.
There's no internet access, so they can't get to an external link.
Yeah. Yes, so, exactly.
So these 2 pictures, like they will be able to like see this particular code.
Yeah.
Okay. So they will add particular code. So so adding this particular code, so which is helpful for this steganography. Okay.
Right.
So next we can move to like 5, which is particular like cipher, which is like an RSA algorithm, where students will be, again, out of this particular scenario where students will uncover that there is another artifacts has been discovered from the adversaries, and the skills are required. And this is like this flag has been given to students, and they will be able to decode and do a frequency analysis on that, and kind of like what is the highest frequency and messages they can do. So if I visit the RSA algorithm in the CryptoTool, so this is like just a second, please. So this is like the encryption, which is the number you can see. We find it back in particular lab. So students will be able to take this lab particularly, and they can decrypt it. And in this particular RSA decryption. So this is the RSA encryption, and then frequency analysis. If we play this one, particularly which was mentioned, then we can see that what is the frequency analysis. So which will help students to find out which letter has been the highest and which letter has been repeated lowest. And that's kind of like giving them different opportunity for learning about different algorithms, what are the outcomes and when it can be used. And they can also play with other algorithms within these crypto tools, and they have different can see like crypto analysis hash functions. They have different templates to use, and also what they can do if they want to build it, they can also build it from the left side. It's like a very innovative opportunity for teachers to even create and help students to see like how to input the text, where to apply different algorithm, and how to get the output as well. Additionally, this particular tool also helps students to, if they want to, they have also a YouTube channel for the future, and they also have different analysis and creativity. So it enhances students' creativity to use this open source tool in their day-to-day activities in the learning cryptography and their interest towards cybersecurity.
Perfect. Thank you so much for the overview. Any last word that you will like to tell our students and educators in the CAE community?
I would like to say to all of our educators, CA communities, and other industry partners who are involved in this project incubation, that this type of incubation lab needs to be conducted multiple times in the United States in the various parts, because it helps not only educators come together, but also having a brainstorm, which generally we always generally do with our own colleagues. So whenever we do, like I and Jessica did with Erie, that kind of like come up with like what type of questions can be best for what age group and how they will approach. And did we come up with the ideas in the first time, the best questions? No, it's a 48 hours, like total 40 hours rigorous incubation. It's like we are stuck and having breakfast, lunch, and coming up with the best questions, what is possible for students level, if they are K-12, and what is their level, so which is kind of our learning purposes as well. So I wish it's keep conducted, and I personally got to learn a lot, particularly how to approach students when they're coming from diverse background.
Jessica?
Yeah, and I would like to add, Devishri and I, worked really hard together, and it was a nice compliment to realize that East Coast and West Coast could come together in Chicago and be able to work together. And it's not that, I agree 100% that there should be more opportunities like this. I think that we're better when we're learning together. We learn also as we do this process. I am all for reusable artifacts. I think it's really important as a community that we do have more artifacts that other community colleges, four-year colleges, people can use and take this and artifacts, and they can implement them into their own programs and be able to say, hey, this was created from here, but it still serves a purpose for what we're trying to learn. We shouldn't have to reinvent the wheel. We should be able to still come together, collaborate together. We have the same problem. It's the entire United States. It's a global issue. It's not just United States. It's how do we get this information taught? How do we collectively come together? And I think more events like this allow more opportunity to be able to say, what is the best approach? How can we get this across to students? So I would agree. I think that this is a great opportunity. I would love to be able to share with my own community of professors and just say, hey, this ever comes up again, try to make sure you go to one of these, because it's been a great experience.
And
fantastic.
I would like to thank Moraine Valley Community College for organizing this and
absolutely.
Giving us
and Colorado, right?
Yes,
Colorado too. Yes.
And I missed that. So thank you for allowing us to be a part of it, and we're grateful for this opportunity. And yeah, I didn't want to steal words from Jessica, but we shared that same thoughts.
Fantastic. What a beautiful message. I would like to thank both of the distinguished guests today, Devashir and Jessica. Thank you so much for your hard work on the incubator. Thank you for the overview. And I'm excited that you enjoyed the incubator. I hope to see you next year, hopefully multiple times next year, as we are working towards more resources for the CAE community. Thank you so much.
Thank
Absolutely, Eri, and thank you so much for being a wonderful leader and organizing this. You've been an awesome project lead and going through this process.
Yes, thank you for your insight. So it's appreciated. Thank you so much.
Thank you.
Thank you, guys.